Okay, we have a negative angle here. And if you think about negative angles, they're just measured clockwise instead of counterclockwise, right? So if I want to know what that angle is, wouldn't it be 2 pi minus 7 pi over 12? Because we're going kind of backwards, right? So if we got a common denominator, I could multiply 2 pi times 12 over 12. And that would be 24 pi over... A little bit bigger, I think. That's okay. 24 minus 7 would be 17 pi over 12. Okay. Okay, so where is that? We know pi is here. Let's see. Get a color. Pi is here. So if I take pi out of 17 over 12 pi, I could subtract 12 over 12 pi, because that's just 1 pi. That would be 5/12 pi here, wouldn't it?
Wait, what?
Okay. I'm trying to figure out what it is as a positive angle. We subtracted it from 2 pi and found out that its positive angle is 17 pi over 12, right?
Mm-hmm.
Okay, so if it's 17 pi over 12, what I did is this is, again, just a fraction thing. If I want to figure out where it is, it's past pi, I know, because 12 over 12 pi would be just pi, right? That's 1 pi. So isn't it 5 over 12 pi past it? Okay. So 5 over 12 pi, that's not going to be all the way down to 270 degrees or 3/2 pi down here, but it's getting pretty close, isn't it? So what we're talking about here is, let's see, this would be 180. 5 over 12 pi. 12 goes into 108. Let me get my calculator. So what if we divided up 180, 12 equal ways? It would be 15, but we got 5 of those 15. So we have a 75-degree reference angle. This 5 pi over 12 is equivalent to 75 degrees. So we have a 75-degree reference angle right here. How could we talk about this? See, that's 180 and 75 degrees. In degrees, that's 255. Sometimes it's just easier for us to work in degrees. It is for me anyway. I don't know about you guys. So how could we get 255 degrees? That's what we have to decide first. Just figuring the angle out is fun, isn't it? Now, one thing that might be helpful, if I look at what's the middle of this third quadrant here? Let's see, 180 and 45. If I had a 45-degree reference angle there, that would get me to 225, right? And so that has a 45-degree reference angle. So if I use that, what would 255, which is the angle I really have, minus that 45-degree reference angle of 225 give me? If I subtract, isn't it 30? Right? So couldn't I say that this is equal to 225 degrees plus 30 degrees if it's 255, right? Now, I suggest we work in degrees and then change the answer back to radians at the very end, because don't we usually think in degrees? And look how much work it's taken just to figure out how we could represent this. Do you notice that one of the things I did when I had to figure the angle out after I got it as a positive angle, that was another whole bag of worms, wasn't it? Was if I see where it is, if you kind of go to the middle, you know, like a 45-degree reference angle, a lot of times it's easier to see maybe what you could use. So if I had something over in the third quadrant over here and I didn't know what to do, I might come over here and say, well, what's a 45-degree reference angle over here? And then see, could I add or subtract something from it to get my angle? Does that make sense? Sort of, not?
Kind of.
Okay. If you're stuck on how to rewrite it, basically look at what quadrant it's in. Go find a 45-degree reference angle and figure out what that real angle is. Like here, my real 45-degree reference angle right here was 180 plus 45 was 225. Right? Let's see. Yeah, 225. That's how I got that. And then I said, well, if I take my angle, 255, and I subtract out the 225, there's a 30-degree difference. So I could say 225 plus 30 is 255. This one has a reference angle of 45 degrees, and then 30 degrees. We know a lot about 30 degrees, okay? So just getting the angle figured out can be the hardest part. That's one of the reasons I started with what we did in class the other day, was that it's the key to figuring this whole thing out. Okay, all right, so now we know what our reference angles are. We decided we're going to work in degrees, change to radians at the end. And notice there's only 3 of these that you had to figure it out on. They actually did some of them for you, so you didn't have to. They're trying to help you out a little bit by saying try something like this. Okay, so I want to find we were supposed to find the sine, cosine, and the tangent. Yay. Okay, so we have a plus. We know we need the formulas that have the plus in them. So actually, after all that erasing, let me just go to a new page. Yes, I heard that song this morning when I was exercising. They were playing it. Okay. It's getting a little old. Okay, so sine of 225 degrees plus 30 degrees. If you remember, we take the sine of the first angle, which they call u, and then we take the cosine of the second angle, which is 30 degrees, and then we add in the cosine of 225 degrees and the sine of 30 degrees. We basically switch the trig ratio we're finding of the angles and add them together. Okay, now we know this is a reference angle of 45 degrees. This 225 is. That's one of the reasons we could use it. Let's put our all students take calculus in there. It's over in this quadrant, so the tangent is positive, but everything else is negative in that quadrant. So the sine, it's a 45 degree reference angle. The sine of 45 degrees, let me put my little parentheses. If I do that, maybe, it can help me just see, I don't know, helps me calm down a little bit. I just know I got to take 4 trig values now. Sine of 45 degrees would be square root of 2 over 2, except in that third quadrant, sine's negative, so we stick a negative on it. So far, so good? Okay, everybody? Cosine of 30, what's the cosine of 30? Sine of 30 is a half, so the cosine of 30 would be the other one, right? Square root of... And 30 degrees, it's in the first quadrant, everything's positive. Now, we're going to do the cosine of 225 degrees, and it's in this quadrant, so it's going to be negative, because the cosine's negative in the third quadrant. And 45 degree reference angle, wouldn't it be square root of 2 over 2 again, right? And then the sine of 30? A half. So if you've got that table made, it would make this go a lot faster. Okay, so
how did we know to be in which quadrant?
Well, remember 220. I'm actually at this point I'm not thinking about the original angle anymore. I'm thinking about these 2 separate angles. So 225 degrees, 180 is right here. 225 minus 180. Well, is it 225 between 180 and 270, right? So that's all I'm thinking. That's how I knew it was there. And we figured the 45 degree reference angle out on that first page. Just that was part of figuring out what we wanted to split it up into. We had to have something we knew.
So would the signs be negative?
Well, oh yeah, they would be on the 225 things. The sine and the cosine would be negative. But remember, when we think of 30 degrees is actually over here, isn't it? You're looking at, once you split it up, you quit thinking about the angle you started with. You've now split it up into 2 smaller things. So yeah, that one's in the third quadrant. 225 is, but 30 is back in the first quadrant. So everything's all positive on that. Okay, this is a good question. All right, so if we multiply this, isn't it negative? Across the top, we get square root of 2 times square root of 3 is square root of 6. And on the bottom we have 4. And then over here I'm going to add, but I have a negative times a positive, which is a negative. So I'm just going to put subtract here. And then square root of 2 times 1 is square root of 2. And 2 times 2 is 4. So I have negative square root of 6 minus the square root of 2 over 4. That's just the sine. Now what do they want me to do? Cosine. We'll just go to a different page for each one. Sine of 225 degrees plus 30 degrees. And if I go look that up, which I'm going to do so that I don't mess up some sign or issue on it, that's going to be the this is the one where you take the cosine of both of them. And then when you're adding them, you actually subtract, which is a little weird, and then you take the sine of both of them. Okay, so I'm just looking at the formula and what it tells me to do. Again, if you need to, if it helps you, you can label this as U and this is V, and this is cosine U, cosine V minus sine U, sine V. Okay? So you can always label them if that helps you think. I know I did it when I first did this, I would label them, but some of you I know won't need to, and some of you may want to for a little while. Okay? Got a question?
So just me.
No, I mean I did when I first. I'll guarantee you I did this when I first started. I didn't understand trig at all the first time I took it. It just 30 years later, ooh, I just dated myself. I'm understanding it a whole lot better, but I still had to be really careful because there's just so many details in there. And that what's hard about it is that all the little pieces that you have to think about, and if you forget one little piece, all of a sudden you might think you're on track, but you're not. Okay, so let's get our all students take calculus thing going again. We know that anytime we see the 225 degrees, what'd you say, Caleb? No, I didn't study it on that 30 years. I actually didn't think about it at all and then came back to it and went, oh, yeah, this is what they were trying to tell me in high school.
You can't say 30 years and then go off on something else. I'm like, wait, what?
You're stuck back a long way back. Okay, let's get down to doing this. Cosine of 225 degrees, we know it's a 45-degree reference angle still. So it's square root of 2 over 2, but it's in this third quadrant, so what's the sign on it? Negative, okay? Cosine of 30 degrees. 30 degrees is in the first quadrant, and cosine of 30 degrees is?
Cosine of 30 degrees is the square root of 3.
Over 2, good. Got my subtraction sign. Sine of 225, negative, square root of 2 over 2 again. At least this is the second time we've looked at some of these values, so it starts to be a little easier. And then the sine of 30 degrees is? A half, okay? Okay, so now all we got to do is just multiply our fractions and see if, get common denominators if we don't have them. Across the top, a negative times a positive is a negative. Square root of 2 times square root of 3 is, again, square root of 6. And 2 times 2 on the bottom is 4. I have a subtraction sign, but then if you look at the two numbers, I have a negative times a positive, which would be a negative when I multiply. So if I subtract a negative, that's the same thing as adding, right? So you got all these little rules that you learned back in junior high to think about. Across the top, square root of 2 times 1 is square root of 2. And 2 times 2 is 4. So we could put it together in one fractions, negative square root of 6 plus square root of 2 over 4. If you were to check the back of the book and they had this, is that the same thing? It actually is, because doesn't the commutative property say, if we just look at the top, the commutative property says I can switch the order I add things in, right? So I can switch them as long as I keep the same sign on them. That negative square root of 6 could be a subtract square root of 6 if I listed that second, and I still have a positive square root of 2, right? Commutative property says it's okay to switch those back and forth as long as we keep the numbers the same, and so we have to remember that the operation sign can also be the sign of the number. They might write it this way just because a lot of times mathematicians don't like to write negatives out front if they can help it. It's just, I don't know, they're picky that way. I'm going to do the tangent of 225 degrees plus 30 degrees. Okay, so we filled in our values. We're running short on time, so we just did that off. So we have, if I get a common denominator on the top, I have, couldn't I rewrite that as 3 over 3 on the top? So that I could have a common denominator on the top, it would be 3 plus square root of 3 over 3 on the top. And on the bottom, I could also rewrite 1 as 3 over 3. So I could have a common denominator on the bottom of 3, and it would be 3 minus square root of 3. Probably Katie's idea of taking the original sine and cosine over each other was a good idea, wasn't it? If we do this now, we'd have 3 plus square root of 3 over 3, and we would multiply times the reciprocal of the denominator.